let us look at another example. Let's take a look. All right, so here's another problem. I'm going to focus on just identities. Here's a problem right here. Here's a problem that says the cosine of 2 theta, let's get rid of this here. Let's get rid of this. Get this out of the way. Doesn't confuse anybody. So we have the cosine of 2 theta, plus the cosine of theta, plus 1. All of this over 1 minus the cosine of 2 theta. All right, let me make sure I wrote it down. Cosine 2 theta plus cosine theta plus 1. And this is over, I think I wrote down the problem wrong. I'm sorry about that. So they're saying that in the denominator here, they're saying that the denominator here is the sine of 2 theta. I'm sorry about that. Sine of 2 theta plus the sine of theta. They're saying that this is equal to the cotangent of theta. All right? So you got to make sure you write down the problem properly. And I think I did that. I believe I did that. All right. So now, this is a mouthful. Anybody who looks at that who's not entirely comfortable with math, they will say, ooh, this gives me a headache. They'll say, this gives me a headache. I hear people say things like that. But if you look at something like this, that's much more manageable, especially for people who are comfortable with math. All right, so let's try to simplify this down so that it's equal to that. And one of the things that you'll have to be able to see, one of the things you have to be able to be aware of coming into this problem is certain truths about these trigonometric expressions. So there's certain things that you would need to be aware of, and one of the things you have to be aware of is that the cosine of 2 theta, is equal to, you'd have to know that the cosine of 2 theta is equal to cosine squared theta minus, oh, you can't see that. Boy, I'm very sorry. Minus sine squared theta. You would have to go into a test knowing that. Or some teachers, what they'll do is they'll provide their students with this identity. And not only is that true, but cosine 2 theta is equal to something else. Cosine 2 theta is also equal to 2 cosine squared theta minus 1. And then cosine 2 theta is also equal to 1 minus 2 sine squared theta. Each of these are all equal to the cosine 2 theta. Not only that, you'd have to go into the test knowing that the sine of 2 theta is equal to 2 sine theta cosine theta. All right, so you would have to, I'm very sorry. You'd have to go into the test knowing this. Or your teacher, some teachers, like I said before, would provide their students with this information. All right, so now that said, you're going to have to use these identities to prove that this left side is equal to the right side. All right, so let's proceed. Let's see how we do. One of the challenges that a lot of students have with this topic is no problem is the same. And I tell my students this all the time. A lot of this is going to come, your comfort level with these identities is going to come with a lot of practice. All right, so let's be patient as we go through this problem. All right, so cosine 2 theta is equal, the cosine of 2 theta is equal to, let's use this 2 cosine squared theta minus 1. All right, now some people might ask, why am I going to use this top one? My feeling is that I'm going to use this top one is because I know that the cotangent of theta is equal to the cosine of theta over the sine of theta. So if I can get cosine on the top, I think that's going to be beneficial for me. I'm not going to use this one because that has sine in it. I'm not going to use this one because, I'm not going to use this one because it does not, I'm not going to use this one because it has sine in it, and I'm not going to use this one because it has sine in it. All right? I'm going to use something that has cosine in it because that's what cotangent means, cosine over sine. All right, so here we go. The cosine of 2 theta, as I told you over here, is 2 cosine squared theta minus 1. So let's replace cosine of 2 theta with 2 cosine squared theta minus 1. All right? 2 cosine squared theta minus 1. And let's bring this plus cosine theta, let's bring that down, and let's bring that plus 1 down. All right? So now what we have is this is over the sine of 2 theta. The sine of 2 theta. We told you that you'd have to go into a test or go into the problem knowing that the sine of 2 theta is equal to this. So let's replace the sine of 2 theta with that. All right? So we have 2 sine theta cosine theta. That's replacing the sine of 2 theta. One of the reasons why you would know that you would have to replace this 2 theta and this cosine 2 theta and this sine of 2 theta is because there is no 2 theta over here. That is a giveaway. That is a giveaway that you're going to have to do something with that cosine 2 theta. You're going to have to do something with that sine 2 theta because there is no cotangent 2 theta over here. All right? So that I'm trying to share with you what would cause you to know that you got to attack that. You got to attack the cosine 2 theta. You got to address that sine of 2 theta. Now let's bring down the plus sine theta. Let's bring down the plus sine theta. And we're saying that all of this has to be equal to the cotangent of theta. All right? So let's keep going. Let's keep going. I'd like you to be able to see here, this minus 1 plus 1, that would cancel out. This would cancel out. So now what you have is you have 2 cosine squared theta plus cosine theta, and this is over 2 sine theta cosine theta plus sine theta. And again, they're saying that this is equal to the cotangent of theta. All right, let's continue. Let's continue. All right, so now what we have is I'd like you to be able to see that you can pull out or factor out a cosine theta. All right, so let us do that. So if you pull out or factor out a cosine theta, you end up with 2 cosine theta plus 1. All right, and then in the denominator, let's pull out a sine theta. You pull out a sine theta. There's a sine theta common between these two. And you end up with 2 cosine theta plus 1. All right? And they're saying that this is equal to the cotangent of theta. And what I'd like you to be able to see is there's cancellation there. So you end up with cosine theta over sine theta. And indeed, that does equal the cotangent of theta that they said that it should. All right, so again, I want you to see that we thought about this. You could waste a lot of time. I could have wasted a lot of time. Cotangent 2 theta here. I could have substituted that 1 minus sine theta, which wouldn't have been wrong. I could have substituted the cosine squared theta minus sine squared theta. That wouldn't have been wrong, but I used a little forethought. I said that I wanted cotangent, and I knew that cotangent was equal to the cosine over sine, and that's why I chose to use that 2 cosine squared theta minus 1. All right, so we've got 5 more minutes left in the show, and we can spend that 5 minutes working with you if you call in. All right, but if you don't call in, I'm going to try to squeeze in one more problem. Identities, okay? I'm going to try to squeeze in one more problem. And let's see if we can do it. Let's see if we can do it. All right. And I think what we're going to do is let's give it a try. All right, let's give it a try. See if we can do it. All right, so the problem I'd like to take a look at, is right here. All right, so let's say we have 2 cosine theta minus cosine 2 theta over cosine. Oh, I don't want to. Yeah, let's do it. Too late now. Let's do it. Cosine theta. All right. So, let's make sure I wrote down the problem right. They're saying that this is equal to secant theta. They're saying that's equal to secant theta. All right. So, let's make sure I wrote down the problem. 2 cosine theta minus cosine 2 theta over cosine. All right. Is equal to secant. All right. Let's give it a try. Another way you could write this cosine theta is you can write this cosine 2 theta as, let's see here. How could we write that? Let's write that as, so we have 2 cosine theta minus, let's write this as the same identity we used before. 2 cosine squared theta minus 1 over cosine of theta. All right, so let's give it a try. And they're saying that all this is equal to secant theta. This is the same identity we used last time. All right, so now what I think I could do is I can distribute that. I'm going to distribute this cosine theta here to the negative 2 cosine theta and to the negative 1. All right, let's put this in parentheses though. All right, so we have 2 cosine theta minus, let's distribute this cosine theta here. We'd get 2 cosine theta. We get 2 cosine theta there. And if we distribute this cosine theta here to the negative 1, we end up with minus 1 over cosine theta. And they're saying that all of this is equal to secant theta. And it turns out, look here, it turns out that, oh, I'm sorry. Let's put all of this in parentheses. I'm very sorry about that. Let's put all that in parentheses because we had a minus sign out front there. All right, so what I'd like you to be able to see here is if we distribute that negative, we end up with 2 cosine theta minus 2 cosine theta. And then you distribute that negative over here, you end up with plus 1 over cosine theta. And they're saying that all this is equal to the secant of theta. All right? So now there's cancellation here, and you end up with 1 over cosine of theta. They're saying that that's equal to secant theta. And anyone, if you're able to follow what I'm doing, you would know that the definition of 1 over cosine theta is secant theta. All right? That's by definition. So again, it didn't turn out the way I really wanted. I was looking to do another kind of problem, but that's okay. My point to you is, given this original problem, that's a mouthful. This will cause someone to say, wow, that gives me a headache, man. That gives me a headache. But if you simplify this down to secant, it's much more manageable. And that's what the purpose and point of this entire topic was today. All right, so that's all we have time for. We only have a minute left. I want to encourage all the students out there to put forth your best effort with your schoolwork. I was talking to a young lady just yesterday evening, and she says to me, "Oh, my friends are goofing around." Well, just because they're goofing around, that doesn't mean you have to goof around. You still put forth your best effort, and you listen in class, and the person next to you, they might be goofing around, but you stay focused, and you ask questions. You come after school and get all your questions answered, put forth your best effort. And by all means, you never quit. You never give up. You never quit. You always put forth your best effort. All right? So that's it. That's all we have time for. I put all these videos on my YouTube channel, which is entitled Dominate Math. God bless you. Thank you for watching. That's all we have time for. Have a good evening, and thank you very much for watching.